Hi everyone, I'm Mohammed, and I am presenting our paper titled Agents of Autonomy, a systematic study of robotics on modern hardware. I'm currently affiliated with NVIDIA, but this research was conducted while I was at Carnegie Mellon University. Robots are rapidly permeating our society, transforming various aspects of life, from economy and agriculture to military defense and healthcare. Despite their huge importance, there remains a long-standing gap between robotics and computer architecture research. This is evidenced by the very few publications in this area. For instance, in 2023, out of the hundreds of papers presented at top architecture conference, only a few were related to robotics. This gap has consequences. When robotics workloads, such as pathfinding, are executed on modern architecture, there's often a mismatch between the requirements of the workload and the capabilities of the underlying hardware. This mismatch leads to slower processing and inefficiency, negatively affecting robots' performance. In this paper, we present RoboWild, a comprehensive open source benchmark suite designed to bridge this robotics architecture gap. RoboWild addresses the lack of a comprehensive robotics benchmark suite for architectural studies. It makes two major contributions. First, it provides a comprehensive cross-platform open source benchmark suite for robotics. Second, it performs a systematic performance study of robotics on modern hardware. To develop a comprehensive suite, we conduct an extensive study of existing commercial robots and their software stacks. We also examined the current state of the art in research, and from this analysis, we extracted common tasks and kernels to use their robots. We implemented these common tasks and kernels and used them to model a variety of end-to-end robots, each designed to resemble a real-world robot. Compared to other benchmark suites, RoboWild stands out with several key features that previous suites lack. RoboWild is comprehensive, encompassing a broad range of tasks. It is high performance, with software meticulously crafted to prioritize performance. The suite is simulator friendly, catering to the needs of architectural research typically conducted in simulation environments. And it is multi-platform. It provides kernels for CPU, GPU, and FPGA implementations. RoboWild is open source and publicly available via this QR code. And the second contribution of RoboWild is studying the architectural implications of robotics on modern hardware. This involves extensive workload characterization and identifying bottlenecks in the architecture. We evaluate the modeled end-to-end robots on different platforms and measure their execution statistics and report their characteristics. This graph shows the execution statistics of Flybot, one of the modeled robots, as an example. The paper includes the statistics for all the modeled robots. An example of the architectural implications study from RoboWild is the observation that robotic workloads often involve substantial amount of unnecessary data movements. This graph shows the fraction of used and unused data out of all data fetched in robotic workloads. It reveals that on average, robots utilize only about half of the fetched data. They leave more than 44% of the total fetched data unused. This example illustrates the mismatch I mentioned earlier, the mismatch between what the hardware offers and the behavior of the workloads. Hardware is generally optimized for a range of other workloads, such as spec, which exhibit good spatial locality. As such, CPUs typically use 64-byte cache lines, and GPUs often use the larger cache lines. However, robotic workloads do not exhibit as much spatial locality. This mismatch leads to significant unnecessary data movement and results in inefficient computing. Other major mismatches to identify in this study include the limited effectiveness of CPU vectorization, the limited effectiveness of hardware and software prefetching, and the insufficient memory bandwidth for massive on-edge parallelism. Thank you for your attention, and I hope to see you in Venice.